critical aspect of API design and implementation. APIs are exposed to sensitive data and functionalities. They are often exposed, right? And protecting APIs from unauthorized access, abuse, or data breaches is essential for maintaining trust and ensuring compliance with regulations. And so there's a lot of key considerations that you need to consider when you're talking about API security. One of the most important ones is called authentication and authorization. And so I like to use this concept before I go into the topic. Authentication ensures that only legitimate users can access an API. But let me break this home for people listening. One, if you had a gated estate and your house was in the gated estate, you would require to give a friend that has come to visit you an access code to come into the gated estate, one. And two, you would also be required to open up your gates to your house, to your friend. So let's bring that back to authentication and authorization. Authentication simply means that you have access to all of these services. That is, from the concept of the gated estate, you have access to go to any one of these houses in this estate. However, you are not authorized to enter each and every one of those houses. You are only authorized to enter the one which you are being opened, with the gate is being opened for you. Note, this same concept applies with APIs. Now, back to the subject. When you talk about authentication, you are allowing only legitimate users to access the estate or the API. And commonly used methods for this is one, API keys. So it is simple to implement, it is less secure as it can be easily exposed, and I'll explain why. Because of bad actors. But these days, for API keys, a lot of the times to clean that up, what people do is, or what users implement these days is something called whitelisting, IP whitelisting. So anyone can steal your API key, but then if their IP is not whitelisted on the server side, they would never be able to have access to they'll never be able to have access to that service because their IP is not whitelisted to have access to that service. Secondly, OAuth, right? This one is widely used and it is probably one of the most popular ones at the moment. It allows users to grant limited access to their data without exposing their credentials. So it includes token-based authentication using access and refresh tokens. Finally, JSON Web Tokens. It's a compact and self-contained way to represent claims between two parties. I'll explain that in a bit, whereby I'll explain OAuth and also explain JSON Web Tokens. JWTs can be signed and optionally encrypted for secure transmission. And all of these support authentication. Whilst for authorization, once you have been authenticated, so you need to be authenticated before you are authorized. It cannot happen in the reverse. Now, once you're authenticated, now you can be authorized. Authorization essentially just ensures that the users have permission to perform specific actions. So you want to implement things like role-based access control or attribute-based access control to enforce things like your permission based off of their user role or their attributes. But really, when we bring them back to the example that we used earlier on, you would note that your friend can only allow you into the apartment based off of the fact that your role you play in their life as a friend, right? So back to the concept, that is role-based access control. Attribute-based access control is similar, because I know you, I know who you are. I am sure you're not a perpetrator. I can let you into my safe space, right? So pretty much that is the concept of authentication or authorization. Obviously, there are these terminologies where we speak about authentication, authorization, but I believe that within this lesson, I've explained those practically well. Now, there's also a concept called zero trust, and it is a concept where no one is trusted by default, inside or outside a network. Verification is a requirement for anyone attempting to gain access to resources on that network. In order to bring this home, right, I would like to use two major use cases to explain this. One, JSON Web Tokens and claims, right? Now, JSON Web Tokens is based off of something called Open Standard RFC 7519. JSON Web Tokens are used as security tokens, first of all. They form authentication, which are sometimes called JWT authentication, right? So I did assert earlier on that authentication types are JSON Web Token is used for authentication, OAuth, and API keys. And I did say two things earlier on. It uses something called a claim, right? And a claim simply, by definition, it provides an assertion about an entity, such as a client application or a resource owner, to another entity, such as a resource server, right? A claim might also be referred to as a JWT claim or JSON Web Token claim, whatever it is, it doesn't really matter. Claims are name and value pairs. They simply relay facts about the token subject. So, for example, a claim might contain facts about the security principal that the authorization server authenticated. The claim presents a specific token that depends on many things, such as one, the type of token, the type of credential used to authenticate the subject, and the application configuration. Now, to bring all of that into perspective, I'll use this design to sort of explain all of this. There are certain characteristics of the token. Number one, right? It has a header, it has a payload, and it has a signature, right? Now, in the header, it is a string generated using base 64. The payload is where you have the claims, which is simply your data, right? The signature is a string generated by hashing the header payload with a secret. And this hashing mechanism uses something called hash 256, right? Now, if you go on JWT.io, you would find this use case scenario. Now, to explain how this works in principle, when you go on your browser, in order for you to generate a token, you need to enter a username and password, right? And that username and password validates who you are. So basically it does an authentication that validates who you are. Once that has validated who you are, it generates a token using a secret key behind the scenes. And by the way, none of this happens like on the front end interface. So essentially, all of this happens behind the scenes. So all you know is that you have entered your username and password. But what really happens on the web browser, it has generated a token, and this is the case of JWT. It has generated a token behind the scenes on the resource server, right? So note that I said two things at the start of this. There is a claim, and then there is a resource server to authenticate that claim. Now, you validate the credentials on the resource server. On the resource server also generates a token, uses a secret key, sends it as a JSON web token back to the web browser. The web browser now sends the JWT or the JSON web token in the header, right, in a secure endpoint back to the resource server. Now, the resource server now validates the JWT with that secret key and sends a response for the request back to the browser. All of this happens within nanoseconds, but this is really what happens behind the scenes when JWT really is coming into play. And I'll give examples. But before that, I want to explain the different types of tokens because I've spoken a lot about tokens here, and I really need to sort of drive this point of what these tokens mean. Number one is that you have something called access token. And an access token is a security token that is issued by an authorization server. This is part of the OAuth 2.0 flow. It contains information about the user and the resource for which the token is intended to use. The second one is a refresh token. Now, this is because the access tokens are valid for only a short period of time. The authorization servers sometimes issue a refresh token at the same time the access token is issued, because once that access token expires, you can simply just impute the refresh token and it would still work as it should. Now, there's something we also call ID tokens, and they are sent to the client application as part of an OpenID Connect flow. OpenID is also a different type of security mechanism. Unfortunately, we'll not be talking about it in this lesson, but I need to open your mind to the fact that there's OpenID, there's JWT, there's OAuth, there's a number of them, right? And it can be sent, but in this case, since I'm talking about tokens, it would be remiss of me not to speak about ID tokens. And they can be sent alongside or instead of access token in this flow. Now, I did mention in JWT tokens where I said registered claims can serve, I spoke about claims, but I didn't really go into in depth where I was meant to speak about the types of different claims, because these different types of claims are in the payload, right? So you have things like registered claims, and these are default claims that are reserved for app usage. You cannot change them. Things like IAT, which is essentially issued at, right? You have things like sub, which is essentially token subject. You have things like EXP, which is expiry time. You have something like JTI, which is unique token identifier. Now, when you move to public claims are defined by your own data. So your own data is simply things like your name, your email address, whatever it is, right? Finally, on private claims are names without any meaning to anyone except between the consumer and the producer of the token, right? So that's really between them two. They've decided and they've defined this is what it's going to look like. In order to sort of bring all of this home, right, I would use a certain concept to explain this, really. Now, all of this would make sense because we have simply just spoken about all of this in the sense. One, there are three different parts of a JWT token. First, the header. The header contains the algorithm, which is an HS256, and the type is a JWT. The second is the payload. Now, the payload contains different types of claims, like I did mention, standard claims, right? Private claims and public claims. Now, those standard claims are defined by JWT and they have specific uses. So you have sub, you have you have sub and you have IAT and the others. Name and admin is basically a public claim, and you sort of submit that for yourself. Now, sub simply gives you the subject of the JWT, and IAT also gives you sort of like what the timing and sort of like information on this. So really, at the end of the day, this entire concept, once it is hashed, what it does, it is produces this. Once all of this information is hashed, that is the header, the payload, and the JWT signature. Once all of this is hashed together, it produces this signature called a JSON Web Token. When we introduced API security, we did explain a concept of authentication and authorization, amongst other things. And we did say that we have various concepts for authentication, one of them being OAuth. Now, to define OAuth is simply an open protocol for authorization that allows users to share private resources to a third party. There are various roles that are included in an OAuth mechanism. Number one is a client ID. A client ID serves as a username for an application. A client secret, number two, serves as a password for your application. Three, you have a resource owner, and a resource owner is an entity that grants access to protected resources. That is the service. That is the server, or that is the service behind the scenes, which is called a resource owner. The resource server, right? Or the resource owner owns it. The resource server holds the resources that the resource owner needs to access. And then you have the client. The client is simply the application that requests access to protected resources, typically for resource owners to use the application. And then you have the authorization server. Authorization server is simply the server that is responsible for accepting credentials from the resource owner, checking if they are authorized to access a restricted resource, and providing an access token to allow access. I'm going to explain a simple authorization code grant flow by using a simple diagram. Walk with me for a second. When a client, and I'm going to use all of these concepts in this diagram, each of these concepts, that is these 6 concepts, that is the client, from the client ID to the authorization server. Each of these concepts typically speaks to certain subject matters. Number one, there is a client app. A client app sends its request, which is simply a token request, to an authorization server, right? An authorization server would validate the client. Once it validates the client is who they say they are, it presents a login form to the user, right? And the user enters a login request that is using their username and password, right? Sends that once they complete that, it's sent back to the authorization server. Now, if that information is validated, or that the credentials are validated, right? It sends back, right? The authorization server will validate the credentials, and it will send back to the user to ask the user consent for the scopes. Scopes are simply things like, do you want us to share tweets? Do you want us to share user information? Just things, scopes are simply a list of permissions that you want the user is sort of asking to do. So simply things like, if for something like Twitter, can we share tweets? Can we share user information? These are simply what we call scopes, right? And then the user will sort of allow access in a typical scenario, right? And that access goes back to the authorization server. Now, for the authorization server to ask, for it to authorize or redirect a URI, it needs to send a request back to the client application once that entire process has been completed. The first process has been completed once you allow access, right? Now, a second process starts again where Now, if you wanted to redirect that URI, say in an authorization code, you want to authenticate that authorization code to the redirect URI, right? In situations where you're not able to meet the first URI and you need a redirect, or you want to create a failsafe, the authorization server requests that from the client app. And once he gets that request, it sends a get token request with an authorization code, a client ID, and a client secret, right? To the server side of the system, which goes back again to the authorization server to complete that process. Now, once the authorization server validates the client ID, the secret, and the code, it sends a token back to the client app, right? And the client app would basically send some protected resources using something called a bearer token to the resource server. Now, that resource server would validate the token itself from that auth server and send a response back to the client app. This entire process that I've just spoken about is what we call an authorization code grant flow. In order for us to fully understand and appreciate this, there are various concepts that I'm basically going to put by the side here to sort of like drive this point forward. So you have query parameters in the token request, things like client ID, your response type, your scopes, your redirect URI, and your state. Now, there are other authorization flows for generating the token. They include implicit grant flow, client credential grant flow, password grant flow, right? And all of these steps follow from step 8 upwards. I've explained step 8. I've also explained step 9. I've also explained step 4 to 8. But all of these different flows follow back to this concept. Right. So before we complete this entire process, I want to sort of drive something home to sort of give some more context to this. And these are something what we call, this is really important, and it's what we call security considerations when you're sort of trying to safeguard against bad actors or just exposure. One of it is called secure communication, under security considerations. Number one is the use of HTTPS. You need to always encrypt your data when it's in transit. Number two is the use of HSTS, which is hypertext strict transport security. You want to implement HSTS to ensure that browsers only communicate with your API over HTTPS. Another consideration is input validation and output encoding. Input validation is simply does something called sanitization of all incoming data to prevent injection attacks, things like SQL injection, things like cross-site scripting. We use something called whitelisting. I did mention this earlier on. We use a process called whitelisting to allow only acceptable input formats. It also involves a process called output encoding, which is simply properly encoding data before returning it to clients to prevent something called XSS vulnerabilities, right? Which is essentially your cross-site scripting vulnerabilities, ensuring that any data returned to the user is safe to display. And that's what I mean by input validation and output encoding. I've spoken about this concept earlier on, so I'm not going to flog it anymore. Rate limiting and throttling. So, implementing rate limiting to restrict the number of requests a user can make between a specific time frame. This will help to prevent abuse and protect your APIs from denial of service attacks, things of that nature. Throttling is essentially controlling the rate of requests by slowing down the responses for users who exceed the defined limits, helping to maintain API performance. Another security consideration is logging and monitoring. So using audit logs to maintain, using these logs to sort of maintain all requests and responses. And I need to say something very specific here. It is really important to never delete anything off of your logs, because this could simply be the difference between you being able to validate a process when you are being audited and basically keeping people away from law enforcement, really. Because sometimes within fintech industries, when you experience fraud, sometimes auditing takes place and your story can only be backed by what is in the audit logs, that is in the request and responses. So things like authentication attempts, change to data, access to sensitive endpoints, all of these things, they would include timestamps, IP addresses, user identifiers, as much as possible. As long as your hands are not dirty, you want to make sure that these things are clean, these things are imputed, and make sure that at the very least, right, anyone that audits this information can corroborate your story to say this person or this professional is telling us the truth. Also, monitoring. Monitoring, there are many reasons for monitoring, but also it helps to detect things like anomalies, potential security breaches, and it helps you to, and you need to sort of set up alerts for suspicious activities, things like high request rates, access from unexpected locations. And this is technically one of the reasons why people use various tools like whereby they don't allow access for location-specific products by people from various locations, as other locations as well, because again, just really trying to protect against bad actors. Another point here is cross-origin resource sharing configuration. Now, you need to configure these types of policies to control which domains are allowed to access your API. So you want to restrict access to only trusted domains to prevent these cross-site request forgery attacks. API gateway security. So I've spoken a lot about API gateway, but really API gateway security is the first step whereby you are sort of just filtering using authentication, authorization, rate limiting, login from that single entry point to manage access to secure your API and your backend services. The next point is on security testing. Now, there's a number of ways that you can test your API, but in terms of security, for testing, for the security test cases, I would use three. Number one, pen testing, that is your penetration testing. You want to conduct regular penetration testing to simulate attacks and identify potential weaknesses in your APIs or that might be vulnerable to attacks. You want to perform dynamic testing as well. Dynamic testing is simply like using automated tools or manual testing to find vulnerabilities in the running of your APIs. And things like another one is called static analysis, where you use tools for static code analysis to identify vulnerabilities in your API code before you deploy it to production. Now, another consideration here is secure data storage. Now, under secure data storage, there are two concepts called encryption and data minimization. With encryption, you are basically encrypting sensitive data at rest using stronger encryption algorithms, right? We spoke a bit about an encryption algorithm with JWT, where we spoke of SHA 256. That's just one, but then there are various methods of encryptions. right? And they are more popular. That's one of the popular ones. But data minimization is limiting the amount of sensitive data stored and processed by the API to adhere to principles of least privilege by allowing access only to the necessary data for a given user or an application. To, to we have got a few more, and one of them is basically regular updates and patch management. Regular updates simply keeping libraries updated, and version management to make sure that you're not you're updating them at the right time, because you want to maintain the right version. You want to, because when you don't maintain the right version, what happens is that there's a bridge in there is sort of like a loophole in there, and it's a potentially vulnerable version that has probably been phased out, and you just open yourself to vulnerabilities there. Other concept is security policies and documentation. So you need to create things like security policies, user education, and this is all involved in your API governance framework. One more concept is called implementation of security headers. So security headers, you can use different types of implementation at the HTTP level. Content security policy, X content type options, and X-frame options. In conclusion, the way I would like to drive API security is that I would like to say that securing API is a multifaceted challenge that requires a comprehensive approach, really. And if you want to really be successful with this, you need to implement strong authentication and authorization mechanisms, which ensure simple things like secure communication, validating inputs, monitoring usage, regular testing for vulnerabilities. Or, and I believe that organizations can significantly reduce the risk of security breaches by simply just adhering to a proactive security strategy. And this includes continuous monitoring, user education, adherence to best practices, and this will just help safeguard your APIs and protect sensitive data.